Okay, let's look again at sine curves, cos curves, and let's move them. So if you're gonna play around with Desmos, which is awesome, I almost refer to it as my friend Desmos, which is pretty sad. But anyway, if you're going to, I cut this off here, so let me see if we can do this. Oh, I'm not good at this. Okay, if you look over here, you have this little screwdriver thing, and I'm on projector mode, so you can see it a little better. But you're gonna want to be careful here. It starts off in radians, okay, and you don't want radians, as you can see, you want degrees. And then I changed everything here. I changed it. You can zoom in, but I changed this to something like my x-axis is going to go from negative to 90. I think I started to negative to 540, and a step of 45. So that means that every solid line here is 45 degrees. My y-axis, I started. It's changed since I moved it, and what happens is if you do move it around, it will then change your y-axis, your max, your min. I think I started at -4 to +4 and steps of 1. Okay, so just be careful. Just make sure you're on the right settings. Otherwise, you can have some wacky stuff show up on your graphs. Okay, so Desmos again, Desmos.com. There's sine curve. Remember, this sine curve starts at 0 and moves up like this. Here I'm done at 3. If I'm finished at 360, that's one cycle. Okay, a period of 360. Turn your head. It looks a little bit like an S. The cos curve, very similar, just shift it over. It starts here. If we're going to start at 0, it starts at 1 and goes down up to 180 degrees, and then it starts to increase after 180 degrees to 360 degrees. Okay, and it gets back up to 1. Both have periods of 1 and max and mins of 1 and -1. Did I say periods of 1? Amplitudes of 1 I meant. Okay, so step 1, we're going to play around with this. We're going to add transformations, and the first thing we're going to do is we are going to put numbers right on the x or the theta. In this case, I'm using x. So let's just look at what happened to sine. So let's get rid of these guys. So my first sine curve is the red one. My second one is the green one here. So I put a 2 in front, and by putting a 2 in front, basically it's going twice as fast. The curve is moving at double the rate, it looks like, okay? But when we're going to describe it, we're going to say that the period is half as big. So I put a 2 in front of the x, and my period from start to finish was in the red 0 to 360, so 360. Now in the green, I'm done here. Okay, I started here, I went up, I went down, I'm back where I started. I end up here. Let's look at cos now and see if we can make a generalization. There's my cos. If I'm going to add something in front of the x here, and I'll put 0.5 or half, you notice now that it is twice as slow, I guess. Okay, that's one way to look at it. So I'm going to scroll out here. And my period now, from start to finish, it was 360, but now I'm going to get up to here. It takes all the way up to this point here, which is 720. Okay, so go all the way from here to here, down a lot slower, and back up to 720. So when I put a big number in front, bigger number, it cuts the period down. And if I put a smaller number, it makes the period larger. And in general, this is our old friend, horizontal compression and transformation, which is represented by the letter K. So what happens is the period is equal to 360 degrees divided by whatever K is. So in my first case, I had 360 divided by 2, and I had a period of 180. Okay, so to get your period, you take K and you divide 360 by it. Okay, back to Desmos. Let's see what happens. Let's go back to our original sine curve in red. I'll zoom in a bit. Okay, so let's zoom in a bit. And now instead of having sine 2, what we're going to do is we're going to play around with in front of the sine curve. So let's first of all, let's throw a negative in front and see what happens. If I just throw a negative right in front, see if you can figure out what's going to happen, and it's going to flip. So I have a reflection here in the x-axis, sorry. So what was 1 is -1. What 0 stays at 0, but any other point here. So if I had something here like negative 30 and a half, 30 degrees is a half high. In my new curve, 30 degrees is, you can guess, negative a half high. Okay, so it's been reflected. So a negative will reflect it, and let's see what else we can get to happen here. Let's get rid of this negative for a second, and let's throw in a 3 and see what happens. Okay, so now it's 3 times as tall, or my amplitude is 3 times as big. So that will lead us to making some generalizations in a second. Let's look at cos. Same thing happens to cos. Same sort of thing happens to cos. So there's my cos curve. What are we going to throw in front of the cos curve? Okay, and again, remember, if something is directly on the x, it affects the horizontal. If it's on the function, when we talk about transformations, so in this case, on the cos, then it'll affect the vertical. Okay, and in this case, we had, let's look at 0.25, okay, or a quarter. Okay, so that's in purple, and you notice now my amplitude here, I haven't shifted it or anything, but my amplitude here, now I go up to a max of 0.25. Okay, so I've taken my amplitude and I've made it 0.25 as big as it was before. And if I throw a negative in front, again, what's going to happen? It's going to flip. If I change this to 6, it'd be 6 times, it'd be flipped and 6 times as big. Okay, so that's what we call a change to the amplitude. Okay, so a vertical distance from the amplitude was the vertical distance from the rest position of the curve to the maximum or min. So this is your A value. So oops. So if you want to look at amplitude, what's going on here? Malfunction. So I look here and I want to figure out my amplitude. My amplitude just will now be with the size of A. So my amp is equal to A. Now be careful. If I throw a -3 sine x, this will give me the negative will give me a reflection in the x-axis. Okay, but don't tell me that the amplitude is -3. The amplitude is a magnitude. It has to be positive. Okay, so it's the positive value of this. Okay, so it has to be positive. The absolute value of -3 is 3. So I want an amplitude given as a positive value, not the negative. Okay, the negative is a reflection. The size of it is the amplitude. Now we're going to shift side to side and up and down. So let's go back to our Desmos graph here. Let's go. We always start with sine. So let's stay with sine. Zoom in a bit. And let's look at a couple things. First of all, let's look at this. If I put it directly on the x here, if I put something right on the x, you should know it's horizontal. But the one thing I want to be careful with here when I type it in is that I use brackets. Okay, so it's right there, and I'm going to move it. Let's say I move it 60 degrees. Oh wait, I don't want to do that. Let's go back here. So back to this. Get rid of this. Just sine x in red. Sorry, and my transformation. Get rid of that 3. I'm going to transform by in green here. Oops. How'd that happen? And I'm going to say -30. And remember, a lot of the horizontal stuff, the opposite happens from what you kind of assume. So remember from our parabola, when you have your h and k in the bracket, okay, so x minus h all squared plus k, okay, your h, if it's x minus 3, you would tell me your vertex is at 3. And in this case also, I have sine x minus 30, I've shifted to the right 30. Okay, so this whole guy's been shifted to the right 30. If this is plus 30, you change your sign and you say that it's been shifted to the left 30 or moved horizontally transformed 30 degrees on the x-axis. Okay, so that's plus is to the left, minus is to the right. And let's look at cos also. Same thing happens with cos. Do we have to do this? Sure, let's do it. For cos, I'm going to, let's move it 90 degrees. Okay, and I didn't put a bracket, so it did something different here. And then there we go. So now I move 90 degrees. The original was my blue. So remember, cos starts up here. And now I'm moving 90 degrees. It says move minus 90. That means right 90. Does that make sense? So I take this whole thing and move it over 90. Okay, that's right. Okay, I was at 0 degrees, I had a value of 1. Now at 90 degrees, I have a value of 1. I was at 0 at 90 degrees. Add 90 to that. I'm at 0 at 180 degrees. So I'm going from blue to purple, blue to purple. Okay, so that is a horizontal transformation, and the horizontal transformation is going to be represented by what's inside the bracket. One thing we do add in here is, so that's your D value, but one thing I want to add in here is, so there's your D. So your D is what you add or subtract. So if I have sine x or theta minus D, okay, so D is your horizontal transformation. The other thing we talk about is this. We talk about the period. Well, the period is not going to change there, okay? But what we would look at the domain, I'm not a huge fan of this, but normally if we look at, let's look at this cosine here, okay? This cosine starts at 0 and ends at 360. So we have a domain of 0 to 360. Well, we're going to say now that we've been shifted over, we're still going to start here at the top, and we're going to end over here. So now our domain also changes. Whatever you shift it also shifts your your domain. So what I'm saying is this: if I have something like this, sine x minus 60, now I'm going to say that my curve starts at 60 and it ends 60 degrees later. Okay, so theta or x there. So instead of being from 0 to 360 as my domain, I add 60 here and I add 60 here. So I start at 60 and I end at 420. Okay, so that's your D value, and that's A, K, D, and what's left is our friend C. Again, I have friends that are not real things, which is kind of strange. But let's see what happens here. Let's go to sine. We'll get rid of the bracket. Okay, so here's our sine curve, our normal sine curve, and let's modify this and put x, and now no bracket, and we're going to subtract. Let's start with the negative. Subtract 1, shift down 1. Okay, so what was at 1 is now at 0. What was at 0 was at now at 1. So this is a vertical transformation. You can make, if it's plus, you can guess it's going to go up. If it's bigger, so let's go to 4. Oops. Go to 4, take the whole thing and jam it up 4. Eventually, of course, we're going to do a bunch of stuff to it. Same thing happens with the cos curve. Okay, and that is our C. C is vertical transformation. And the other thing you want to do is, so that is going to change your axis to, or your rest position. So one way to look at it later on when we add a bunch of things is, forget about how tall it is. Think about what happened to the rest position. Rest position was 0. Rest position is 4. So rest position was 0. Rest position is -2. And that's going to come into play when we start flipping things. Okay. Then you start asking yourself, hold on a second, how much of my moving stuff, if I move 50 degrees to the left and I move this and I move that, let's see if I put a bracket here if this will work. 50 degrees, which is a weird amount. Let's go 60. And then let's say that I take this here and I'm going to change the period and I'm going to flip it and I'm going to stretch it and I'm going to do all these, negative, too much. We go -2, and you ask yourself, okay, now I can't keep track. How did it move up or down? Look at the rest. The rest is halfway between the top and the bottom. Here's the top, here's the bottom. Okay, in the middle is -2. Where's that -2? Actually, you know what? Let's change this to -3. Okay, so halfway between here, between 1 and -5, right in the middle is still -2. This -2 is what's happened to the rest position. So it's hard to keep track sometimes. Did the top move? The top didn't even move here. I moved this entire thing. So if I go from the sine curve, the red sine curve, to the green one, and I say I've moved it, well, I haven't moved the top at all. My max is still 1. But what I've done is I've recentered the curve by moving the rest position to units. And then I stretch it and I pull it and I do a bunch of different things to it also. That'll come up later. Okay, but think of that. AKDC. The C is the movement vertically of the rest position. And that's all I got for you. Let's check it out, go over that stuff, and then tomorrow we'll sketch these things. Hey, what did I just do there? Anyway, see ya.